Okay, so let us look at a very simple and a small demo. Alright, so the demo will take you to the collab.research.com. That is where I have hosted this. It is also available as part of the GitHub that I mentioned earlier. It is a very simple application where NLTK has implemented the BLEU for us. It is only the question of writing the candidate sentence and the reference sentence, and then use the library to run the application. That is it. So, it is very simple. There is nothing great in this application. So, we will just verify what we have learned so far in the theory and see how it really correlates with what we have learned. So, one thing that I mentioned earlier is BLEU looks at all n-grams, unigram, bigram, trigram and 4 grams. Okay. So, it provides weights equally. So, for every gram it provides a 0.25. Here I have just modified that for the sake of understanding this a little better, right. So, you can change the weights the way you want. So, for example, you want to give a very high value for unigram, you can give it as 1 and then reduce the rest. The maximum value that I can provide is 1. Okay. So, I can just have 0.25 instead of 1 here, like you can uniformly provide the same weights for all the n grams. Okay. So, here what I have done is there is a reference sentence, as I mentioned earlier. BLEU requires multiple references. So, I am just cheating here with just one sentence and then calling it as a list of list. Okay. For the sake of quick understanding. So, I have one sentence here as a reference and then there is a candidate sentence, and then I am using the translate BLEU score from the NLTK and calling that function by providing the reference value, candidate value, and then how the weight should be distributed. Okay. So, in this case I am only taking the unigram value and nothing else. So, if you look at this particular example, the reference and the candidates are the same, or I can say the other way, the candidate translation is same as the reference translation. So, we expect the value to be equal to 1, right. So, this is what we have got when you run this. See, for example, I am running only test 1 and test 3 right now. So, the first one it prints out as 1, okay, the value is printed as 1 here. So, I can go and then change this. So, for example, let me go and then change it to something else. I am sorry, that is the reference one. Let us not change the reference, that is gold. Let us say I am changing this. So, the candidate now has only 3 references that are matching with the reference sentence. Okay. So, what should be the value? It is not going to be definitely 1, and we know that we are only using the weights for unigram. So, the other weights are not considered. The sentence is almost the same except for this particular word. So, when you run this, value that get is 0.75. That means, if there are 4 words, only one word is wrong here. So, it is 3 by 4. So, that is the value you get as the result. Okay. So, this is one example. So, if I can just increase the number of words, right, in the candidate. So, what is going to happen? So, this sentence is already long. So, BLEU is not going to be giving any extra penalty for this number. It is already penalized when you compute the score. So, it says now 0.8, correct. So, if I change this to suppose, do I get a different value? We don't, because the reference has only about 4 words. Okay. Let us move on to the next one, or let us now start looking at the variations one after the. So, let us start providing some values. We provide equal value for all the n grams. Okay. So, when I run the score, it is, let us make some mistake here. Okay. Intentionally we do that, and then let us see what the value it is going to be. So, now it is no longer 0.75. See, the value has come down because we are now including bigram, trigram and 4 grams. It is also going to give you some error if it did not match the bigrams, trigrams and quadgrams. So, this is the error that you get. So, it says that 0 counts of 3 gram overlaps. So, it says the score might be inconsistent. Okay. So, this is one error that you made, because you are not really having a trigram references. Okay. So, I am taking a second one. So, in the same fashion you can make changes and then see how the BLEU score changes. Okay. So, this really helps you in understanding how the score is computed. It is very explicit in terms of especially the implementation is very explicit. We would be able to change the weights and then see how those weight the changes are playing with respect to the score and so on. So, there is also a longer score given. So, I would rather request you to go to this place, copy the code maybe in your local machine and then make changes in the candidate and the references and then see how the scores are computed. Okay. So, the whole paper containing about 8 or 9 pages of explanation is brought down to 3 lines of code here. Okay. So, how nice it is. Okay. So, this really helps you in terms of understanding the paper as well. So, I request you to go and then read the paper and understand what they have been talking about and how they really used it to compute scores for various translations, and then what kinds of tricks they try to bring in while bringing in the standards. So, all those things would be very clear if you read the entire paper. All right. And this standard has been used by many. Okay. So, you will see a lot of references to BLEU when you read the machine translation papers. They will be talking about the BLEU scores so on. So, sometimes you do not see a score between 0 and 1, you will see a percentage of the matching. All right. So, BLEU is, as I mentioned earlier, it is meant for the corpus. Okay. We can use it for machine translation, we can use it even for image labeling. You remember we spoke about very briefly how you can label or give title to the image based on the contents of what you find in the image using some language models, right. So, it is also generating some sentences and you want to make sure that the sentence that it generated has some meaningful score with respect to adequacy and fluency. All right. Another task is text summarization. So, in this case you have given a long passage and then you have to summarize it into a few lines. So, again there will be some gold standards available for this. We can compare the candidate sentences that we have generated using this text summarization application and get the scores as well. Okay. This could be also used in the speech recognition. This has lots of usages and not just for machine translation alone. Okay, there are other metrics that you will find, and they are also gaining popularity. There is one called NIST, National Institute of Standards and Technology. They have a standard. I think it's not the name of the standard. It's only the name of that institute, I guess. Okay, so there is one standard developed by NIST that's also based on BLEU. There is some shortcoming that you have seen, right, in the BLEU with respect to not really using the context of the sentence with respect to the semantics, right. So many versions of standards have started evolving. One such standard is Meteor. The Meteor, what it does is it uses stemming and synonymy matching. Okay. So instead of when you have words like say I use and I am using, we don't want to penalize the translation for this sake. Okay. So we use stemming to make sure that we use a root of this, so that the root of this as well becomes use or sometimes us. And then you can compare the words which are stemmed. When you do that, you will get a lot more matching than what you find using BLEU, right. So Meteor uses that kind of a model. Okay. And then there is one more standard called WER, word error rate. It uses edit distance. This edit distance usually was used to find these spelling errors. So in this case, again, the same mechanism is used to find the distance between the translations. This gives you some score with respect to the candidate sentence and the reference sentence. Another one is Google based BLEU. So this correlates very well with BLEU. It's very similar to BLEU, but it's used at the sentence level translation. All right. Okay. So this is a very important topic. This is used for really finding out how well my translation systems work. Okay. So I wouldn't have spoken everything about the paper in this particular session. I probably would have missed a few. All other standards are very similar to that. There are mechanisms similar to what you have seen in the development of the standard of BLEU. You would also be able to go and then read a paper related to Meteor and see how they are really evaluating translation and how they have evolved the standards as well. All right. So there is one more thing that I would be talking about, which is very crucial in the machine translation. I'll be taking a separate session on that as well. So that would be on the beam search. You remember every translation system provides a lot of hypotheses because of your translation probability as well as the language model, right. So which one will I take? So every time for a given word there are possibilities that are coming in, right. If we use a language model for this word, if I use a bigram, what could be my next word, right. There are options. So that gives you several options with respect to the size of your vocabulary, right. So where will I stop, so that I don't need to go really to the bottom of my entire vocabulary stack to find my word. So beam search uses some tricks to avoid that and helps you in terms of improving the speed of finding the right sentences for the translation. Okay. So, we will talk about that later.